China's Impossible Mountain Dam Project explained. $100 billion engineering wonder. For decades, humanity has pushed engineering to places once considered impossible. We built bridges over oceans, tunnels beneath mountains, and cities in the middle of deserts. But deep within the rugged mountains of China, engineers attempted something even more ambitious, constructing a gigantic mega dam between towering cliffs in one of the most dangerous and difficult landscapes on Earth. This is the story of China's Impossible Mountain Dam project, and how thousands of workers transformed a violent river valley into one of the greatest engineering achievements of the modern era. Far from China's crowded megacities lies a remote mountain region filled with steep cliffs, unstable rock formations, and powerful rivers cutting through deep valleys. For centuries, these rivers were both a blessing and a threat. During rainy seasons, floods destroyed villages and farmland. In dry seasons, electricity shortages slowed industrial growth. China needed a solution that could control water, generate massive amounts of power, and support economic expansion for millions of people. But there was a problem. The only location capable of producing enough hydroelectric energy was buried deep between enormous mountains where almost no major infrastructure existed. Building a giant dam there sounded nearly impossible. Yet China decided to do it anyway. Hydroelectric dams are among the most powerful energy systems ever created. By controlling the force of flowing water, they can generate enormous amounts of clean electricity without burning fossil fuels. China's rapid industrial growth created an enormous demand for energy. Coal plants alone could no longer support the country's expanding cities, factories, and transportation systems. The mountain valley offered one major advantage: elevation. The river flowed through a narrow canyon with an extreme height difference between upstream and downstream water levels. That natural drop created perfect conditions for hydroelectric generation. The steeper the drop, the more energy the turbines could produce. Engineers realized that if they could block the river and create a giant reservoir, the dam could supply electricity to millions of homes. But first, they had to overcome nature itself. Unlike dams built on flatter terrain, mountain dams face extreme geological dangers. The cliffs surrounding the project were unstable and vulnerable to landslides. Heavy rain could trigger falling rocks large enough to destroy equipment instantly. Some mountain slopes were so steep that workers could barely stand on them safely. Before construction even began, teams of geologists spent years studying the mountain structure. They drilled deep into the rock to determine whether the cliffs could support the weight of billions of tons of water. In some areas, engineers discovered dangerous fault lines and weak rock layers hidden beneath the surface. That forced them to redesign major parts of the project. Entire mountain sections had to be reinforced using massive steel anchors drilled deep into the rock walls. Thousands of tons of concrete were sprayed onto unstable cliff faces to prevent collapses. Even building access roads became a huge challenge. At the beginning of the project, there were almost no roads leading into the valley. Heavy construction equipment, giant turbines, cement, steel, and machinery all had to be transported through dangerous mountain terrain. Workers carved roads directly into cliffs using explosives and tunnel boring machines. In some places, roads hung hundreds of meters above the valley floor. Massive bridges were also constructed just to move materials across the river. Every day was dangerous. Falling rocks, unstable weather, and dense mountain fog constantly threatened construction crews. Some workers spent years living inside temporary camps built along narrow mountain ledges. Despite the risks, construction continued around the clock. One of the most dramatic moments in any dam project is river diversion, temporarily redirecting an entire river so the main structure can be built on dry ground. For this project, engineers first dug enormous diversion tunnels through the mountains themselves. These giant tunnels acted like temporary artificial rivers. Once the tunnels were ready, crews built giant cofferdams, temporary barriers designed to force water away from the construction zone. Then came the critical moment. Explosives and heavy machinery sealed off the natural river path, pushing millions of liters of water through the diversion tunnels. For the first time in centuries, parts of the riverbed became completely dry. Workers immediately rushed in to begin building the dam's foundation. The dam itself required an unimaginable amount of concrete. Gigantic mixing plants operated day and night, producing continuous streams of material transported by trucks, conveyor belts, and cranes. But pouring concrete into a mega dam is not as simple as filling a mold. Large concrete structures generate heat as they cure. If temperatures rise too quickly, cracks can form inside the dam, weakening the entire structure. To prevent this, engineers installed cooling pipes throughout the concrete blocks. Cold water circulated inside the structure to control temperature during construction. The dam was built layer by layer over several years. Tower cranes moved constantly above the canyon, lifting steel reinforcement and machinery while workers battled freezing winters and intense summer heat. Slowly, the giant wall between the mountains began to rise. Inside the dam, engineers constructed enormous power chambers containing some of the largest hydroelectric turbines ever built. Each turbine weighed hundreds of tons and required extreme precision during installation. When water from the reservoir flows through giant intake tunnels, it spins the turbines at incredible speed, generating electricity for entire cities. The amount of power produced by a mega dam can rival multiple coal-fired power plants. High-voltage transmission lines were then built across mountains and provinces to carry electricity over massive distances. This transformed the remote mountain region into a critical energy hub for the country. Projects of this scale always come with enormous social and environmental consequences. Entire villages near the future reservoir had to be relocated to safer areas before flooding began. Thousands of families moved away from places their ancestors had lived for generations. Environmental experts also warned about ecosystem damage, changing river habitats, and long-term geological risks. Large reservoirs can sometimes increase pressure on surrounding fault lines, potentially affecting seismic activity. China faced criticism from environmental groups, but officials argued that the benefits of clean energy, flood control, and economic growth outweighed the risks. The debate surrounding megadams continues even today. After years of construction, the final stage finally arrived. Engineers slowly closed the diversion tunnels and allowed water to begin rising behind the dam. Over weeks and months, the narrow river valley transformed into a gigantic artificial lake stretching deep into the mountains. As the reservoir filled, pressure on the dam increased dramatically. Thousands of sensors monitored every movement, vibration, and temperature change inside the structure. The world watched closely. If successful, the project would become one of the greatest engineering accomplishments ever completed in mountainous terrain. Today, China's mountain mega dam stands as a symbol of modern engineering ambition. The project generates massive amounts of renewable electricity, reduces flooding risks downstream, and supports industrial development across multiple regions. But beyond energy production, the dam represents something larger: humanity's determination to reshape nature on an enormous scale. From dangerous cliffs and violent rivers to giant turbines hidden inside mountains, every part of the project pushed engineering to its limits. What once seemed impossible became reality through technology, planning, and relentless construction. And as countries around the world race to build larger and more advanced infrastructure, projects like this may only be the beginning. The next generation of mega engineering could be even more unbelievable.